Welcome back to this channel for solutions of practice problems for actuarial exams. Here you have some websites with information about me and things that I do, and the actuarial program at Illinois State University, which is a Center of Actuarial Excellence as recognized by the Society of Actuaries and won the 2016 Casualty Actuarial Society University Award. As you can see, I use this redirect service smarturl.it, and then /, and after that you write a word that is easy to remember, and this redirects you to the website that you want it to point to. So if you want to find out about me, just go to smarturl.it /Jedi. And if you want to find out about online seminars that I run, go to smarturl.it /BTDT-online. And BTDT is what I suggest as the method for studying for actuarial exams. You have to be so prepared for the exam so that on the day when you take the exam, when you look at every problem, you should be able to say, been there, done that. Because you have done problems like that, you know what to do immediately. You don't have to spend time on unnecessary things. Because, please remember, on the real exam, you have 5 to 6 minutes per problem. Here's our problem for today. It's a study note FM-09-17 for exam FM on financial mathematics, problem number 85. The present value of a perpetuity paying 1 every 2 years with first payment due immediately is 7.21 at an annual effective rate of I. Another perpetuity paying R every 3 years with the first payment due at the beginning of year 2 has the same present value at an annual effective rate of I plus 0.01. Calculate R. This is something I would like you to remember. If you're serious about passing exam FM, you should remember these three formulas. That the present value of $1 paid at time n, one time only payment, is v to the nth. The present value of an annual perpetuity of 1 with first payment at time n is v to the nth times 1 over d. In particular, this tells you that if you have a perpetuity due with annual payments of 1, then its present value at time 0 is 1 over d, because the first payment comes at time 0, so v to the 0 is 1. Then the third formula is that the present value of an annual increasing perpetuity of 1, 2, 3, and so on, with 1 paid at time, the first time of the payment, which we assume here, the first payment being at time n, is v to the nth times 1 over d squared. And in particular, if this perpetuity is a perpetuity due starting at time 0, then this is v to the 0 times 1 over d squared. So that tells you that the present value of an annual perpetuity due starting at time 0 increasing in this fashion, 1, 2, 3, and so on, is 1 over d squared. You should have these three formulas memorized for the day of the real exam. Okay, so we have the solution here. The first perpetuity makes payments every 2 years, and it's a perpetuity due. So we're going to treat 2 years as a unit of time, and we will figure out the discount rate applicable to it. The effective interest rate over a 2-year period, I'm going to call it J, is such that 1 plus I squared is equal to 1 plus J, so J is 1 plus I squared minus 1. The discount rate corresponding to it is J over 1 plus J, so it's 1 plus I squared minus 1 divided by 1 plus I squared. So the present value of the first perpetuity, which is known to be 7.21, is 1 over this d sub j, which is the reciprocal of what d sub j is. So it's 1 plus I squared over 1 plus I squared minus 1. But that's an equation with I being the unknown. So we multiply it out, and we solve it, and we get I to be the square root of 7.21 over 6.21 minus 1. It's about 7.75%. For the second perpetuity, we're going to use the interest rate of I plus 0.01. Well, that's really I plus 1%. So that's 8.75 approximately. The effective rate of interest over 3 years applicable to the second perpetuity is therefore 1.875113 cubed minus 1. That's about 28.62%. And the corresponding discount rate over a 3-year period is the interest rate over 1 plus the interest rate, and comes out to be about 22.25%. It's the thing over 3 years, though. The first payment of the second perpetuity comes at time 1, at the beginning of year 2. Now that's intentionally slightly confusing. You see the number 2, you might think that it comes at time 2, but it says that it comes at the beginning of year 2, which is at time 1. The value of the second perpetuity at time 1 is, well, it's the present value of a perpetuity due with annual payment of R. Well, not annual, triannual, but if we treat the 3 years as the unit of time, then it's payment of R per period, and the discount rate applicable to that period is that 22.25%. So R divided by that D is the present value of that perpetuity. Its value at time 0 has to be that value discounted by 1 year under the interest rate applicable then, which is that 8.75%. But that's equal to 7.21. So we set up an equation here. And from this equation, R is approximately 7.21 times this 22.25% times 1 plus that interest rate that we figure out that is applicable to the second perpetuity. And this comes out to be about 1.744637, and that's answer D. Please remember this is copyrighted material. And please remember also that problems posted by the Society of Actuaries belong to the Society of Actuaries and are used only here with permission. Good luck in your studies and good luck on the exam.